The cold goes into your skin.
Well, that's a pretty creative answer, Emily, but it's not correct. All right, Stevie, why do you feel colder after you get out and you're still wet? Well, let me ask you this. Maybe here's another way to approach it. Why do you stop feeling colder when you're dry? Why do you stop feeling colder when you're dry? You're going all around Robin Hood's barn. I think that's an old saying they used to use when I was your age.
Robin Hood.
You're going all around Robin Hood's barn, dancing around the universal law that is involved in this focus. Why do you stop feeling cold when you're dry? Megan.
Because when the air blows on you, all the air is drying the water, so it makes the water colder. And then once the water melts on you, the heat.
That's good, but it's not complete. Okay, Stevie thinks she knows.
Because when you're in the water, you have to.
We're talking about when you're out of the water and you're still wet. Why do you feel colder?
Because you're not moving around.
No. Tanner.
Because all the water evaporates off you.
And what happens when the water evaporates off of you, Tanner?
And then you get warmer.
What does it do? What does the water do when it evaporates? Joey?
It takes heat with it.
Hey, Joey's the first one. This is Joey's first session and he already figured it out. When a liquid evaporates, it absorbs heat. What happens to the water that's on your skin after you get out of the water? What happens to that water? What's the word? What does it do? It evaporates. When it evaporates, what does it absorb?
Heat.
It absorbs heat. Does it make you warmer or colder?
Warmer.
Warmer?
Colder. Cold.
Well, it can only be warmer or colder. If it absorbs heat from your skin, it can only make you colder. All right, now, here's an easy follow-up to that. Explain why you stop feeling cold when you're dry. Why do you somebody ought to be able to do that now. Okay, Joy, I'm going to give you another chance.
Because there's no water on you for it to evaporate.
So therefore it can't absorb any what?
Heat.
Therefore it can't make you what?
Colder.
Good, Joey. Joey's a rapid learner. Okay. Joey's making for lost time as far as his voice appearing on the videotapes. Okay. When the liquid evaporated, absorbed. Okay, one more sentence. Who doesn't have this copy? Who doesn't have this copy? Well, get it from somebody else then if you don't have a copy, because I want to write the rest of the conclusion up here. Okay. We're not done with the conclusion yet. And I'm going to take my box down so that the camera can see the conclusions.
Whoa.
I'm not sure I told you, the only purpose of the box was to hold the thermometer so I could see them. Okay, this is all valid and good so far, but it's not complete because we have to say something else. I'm going to read the whole thing to remind myself of what I wrote, okay? Because A is alcohol, B is water, C is air. Each of these has a different rate of evaporation. When the liquid evaporates, it absorbs heat. Who can tell me once again what the definition of evaporation is? When does something evaporate? What evaporates? What's the only thing that can evaporate, Tanner?
Fluid.
Huh? A liquid. A liquid. A liquid. Okay. When a liquid evaporates, it absorbs heat. The faster liquid evaporates, the more heat it absorbs. All right. The faster a liquid evaporates, the more heat it absorbs. Therefore, somebody in here should be able to tell me Which of those three substances evaporates fastest? Which one evaporates fastest, Nathan?
Water,
No.
also air.
Well,
Water.
you covered all three, Nathan. Which one of those three evaporates fastest based on that sentence? Chase?
Water.
That's what Nathan said. Emily,
Alcohol.
how do you know that alcohol evaporates faster? What is it on the chart that tells you that alcohol evaporates faster, Emily?
Because it has the lowest temperature.
It has the lowest temperature. If more heat is absorbed from an object, the object gets colder. Okay? Now here's an application for you to think about. Suppose you've got a swimming pool and your neighbor has an identical swimming pool, and your pool is filled with water, and your neighbor's pool is filled with alcohol. Okay? You'd have to buy a lot of bottles of alcohol at Plaza Market to fill a pool. Okay. You jump in the pool with the water, get out, you feel colder. Okay. You jump in the pool with alcohol, and you feel even colder. Why do you feel even colder when you get out of the pool of alcohol, Stevie? No. Why? Emily H?
Because it evaporates faster and takes away.
When you get out, the alcohol on your skin evaporates faster than the water on your skin. And if a liquid evaporates faster, it absorbs more heat. Okay, that is now complete. This all goes on the top half of your record sheet. The chart goes on the bottom. Well, we're done with writing. You don't have to do any more writing. But I'm going to describe an experiment, a couple of experiments that apply to this focus. Okay. Copy that down. I'll get out of your way so you can copy it. Now, we're going to experiment with four liquids. We're going to experiment with liquid A that evaporates faster than alcohol. We're going to experiment with alcohol. We're going to experiment with water. And we're going to experiment with a liquid that evaporates slower than water. Faster than alcohol, slower than water. Okay. This liquid evaporates faster than alcohol. Therefore, when you get it on your fingers, it feels colder than alcohol. This liquid is found mainly in girls' bathrooms. And when girls use it, they put it on a cotton ball to use it. What is it? Fingernail polish remover. Nail polish remover. Nail polish remover. Okay. Raise your hand if you've ever gotten fingernail polish remover on your fingers and you notice it felt cold. Well, even Jacob and Nathan have. Okay, and Jake too. Okay, what does that tell you about those boys? Okay. Why does it feel colder than when you get water on your hand? Why? It evaporates faster. Okay, now we're talking about a liquid that evaporates slower than water. Slower than water. Okay, it's a liquid found in the kitchen. When people are going to do a stir-fry meal, they often put this in the wok before they put the vegetables in for the stir-fry. What is it, Nathan?
Oil.
Cooking oil. It could be mazola, it could be sapola,
Canola oil.
it could be cottonseed oil, it could be olive oil.
Canola.
Okay, now, that's the order in which they evaporate. Fastest, slowest. Okay, on a glass dish, we're going to put a drop of each one of those. This is going to be A, nail polish remover. This is going to be B, alcohol. This is going to be C, water. This is going to be D, cooking oil. All right, now we're going to put a drop there. Right away after that, we're going to put a drop there, a drop there, a drop there. 4 different liquids. We're gonna time to see how long it takes for it to disappear. This one, who can tell me which one's gonna disappear first? Which one will disappear first, Allie? Nail polish remover. Which one will disappear last? Darby? Cooking oil, okay. Now this one will, the nail polish remover will disappear in about a minute. The alcohol will disappear in about 5 minutes. The water will disappear in about 20 minutes. And the cooking oil will disappear in about 1 month.
Whoa.
Why will it take so long for the cooking oil to disappear, Stevie?
Because it takes longer to evaporate.
Right. If you've ever spilled oil anywhere and didn't wipe it up, you know that it seems to stay there forever because it evaporates so slowly. Okay, now we're going to do a different experiment with the same liquids, but now we're going to put those drops on your arm like this. A, B, C, D. Raise your hand if you can tell me which one will feel coldest. Which one will feel coldest, Tia? A, the nail polish remover. Who besides Tia can tell me why the nail polish remover will feel the coldest? Why will it feel the coldest, Wyatt? It evaporates the fastest. Who can tell me which one of these 4 will feel the warmest? Which one will feel the warmest, Chase?
Cooking oil.
Well, who besides Chase can tell me why the cooking oil will feel the warmest? Joyce?
Because it evaporates the slowest.
Because it evaporates the slowest, right. Right. So this is an extremely important universal law. What do I mean when I call a statement a universal law? What does that mean? If it's universal, what does that mean? Anybody remember what I told you a universal law means? Nobody remembers that? Well, somebody ought to be able to figure it out from the way it's spelled.
Oh.
Anybody want to guess what a universal law is, Emily B?
The whole the whole universe.
It's true everywhere in the universe. Other planets, other solar systems, other galaxies. Right. It's true everywhere in the universe. Very important scientific law. Each one of my lessons revolves around a different universal scientific law. So by the end of this program, by the end of the 20 lessons at the end of the year, you should know more about more universal laws than your parents probably do, because your parents didn't have this kind of a program when they were in school. Okay, that's the end of this focus.